Hello students, today we will study a new experiment in paper second, study of XOR gate. So we know that the equation of XOR gate is y is equal to a XOR b. See here, this is the symbol of XOR gate. It is a two input XOR gate. The logic equation of XOR gate is y is equal to a XOR b. That is, when the inputs are even, that is 0 0 or 1 1, then the output of XOR gate is low or 0. But when the inputs are odd, that is when inputs are 0 1 or 1 0, then output of XOR gate is 1 or high. Okay, so for odd inputs, the output of XOR gate is high, and when inputs are even, that is 0 0 or 1 1, then the output is 0. Okay, so we have to first verify the truth table of XOR gate in this manner. This is the truth table of XOR gate, and we have to observe the outputs for various the input conditions, that is for 0 0 or 0 1 or 1 0 or 1 1. What is the output of XOR gate? So we have to verify this truth table. Okay, see here, this is the practical board of XOR gate IC 7486. IC 7486 is a quadruple two input XOR gates. Means in this IC there are 4 XOR gates. Okay, the pin diagram of XOR gate is you have already seen in first XOR gate. Pin number 1 and 2 are inputs, and pin number 3 is output. Then in second XOR gate, pin number 4 and 5 are inputs, and pin number 6 is output. Then pin number 7, it is a ground pin. It is connected to negative terminal of the 5 volt DC power supply. Then in third XOR gate, pin number 9 and 10 are inputs, and 8 number is output. Okay, see here, in third XOR gate 9 10 are inputs, 8 output, and pin number and in fourth XOR gate pin number 12 13 inputs, and pin number 11 output. In first XOR gate, pin number 1 2 inputs, 3 output. Then in second XOR gate, pin number 4 and 5 inputs, pin number 6 output. Okay, so and pin number 14, it is a plus VCC. This pin is connected to positive terminal of the DC power supply. Okay, see in backside, see here, this is a step down transformer. Its primary is connected to this mains cord, which is connected to 230 volt AC supply, and secondary wires are connected here to this PCB. On this PCB there are 4 diodes. It is a bridge rectifier circuit. Bridge rectifier circuit consists of 4 diodes. Then this is a filter capacitor, and this is a IC 7805. It is a 3-pin IC regulator. Pin number 1 input, pin number 2 ground, and pin number 3 output. 1 2 3. Okay, and the output terminals of the power supply. Output is connected to the output terminals of the power supply. See here, these are 2 output terminals. This is a positive and this black is negative. So see here, this is a positive terminal. So here blue wire, this blue wire is connected to the positive terminal. And yellow wire, this wire is connected to the negative terminal of the power supply. This is the negative terminal. Okay, so in this way, this is a 5 volt regulated DC power supply. This 3-pin IC regulator is connected 7805. It provides a 5 volt DC. Okay, then this is IC 7486. This is IC 7486. It is mounted on this PCB. It is mounted on IC base 14 pin IC socket or 14 pin IC base IC7486 is connected, and this is a pin number 1, this is pin number 2. It is these pins are connected to these button sockets, okay, or banana sockets. These wires are connected here to this banana socket. So these these pins are actually connected to these terminals, corresponding terminals. This is pin number 1 is connected here to this socket, banana socket. Pin number 2 is connected to this terminal or socket. Pin number 3, it is connected here. In this way, all these pins are connected to these banana sockets or button sockets. Okay, these are the LEDs, and these are the series resistors, 330 ohm. These resistors are connected in series with LED. Okay, the LEDs are connected here, and cathode of each LED is shorted and it is connected to the ground. It is connected to the ground. Ground means pin number 7. See here, this is pin number 7 and it is connected to ground. So all these cathodes of LEDs are connected to ground pins. These are two-way switches or one pole two-way switches. One terminal of each SPDT switch, single pole double throw SPDT, or one pole two-way. It is also called as one pole. This middle is a pole and these are two ways. So this is a SPDT, single pole double throw, or one pole two-way switch. So one pole and two-way switch. So each one terminal of each switch is shorted here and it is connected to plus VCC, and other side terminals are again shorted and it is connected to ground. In this way, the input is either connected to plus VCC or connected to ground. When the input is connected to plus VCC, then that input becomes high, and when it is connected to ground, the input is connected to ground, then the input becomes low. So one side is connected to plus VCC and other side is connected to ground, and actual input is connected to this middle terminal. It is a pole. Okay, so this is a one pole two-way switch or SPDT switch. Okay, now first of all we have to verify XOR gate. We have to verify each XOR gate. So in first XOR gate, pin number 1 and 2 are inputs and pin number 3 is output. First we have to connect a DC power supply here. So connect a positive terminal of the DC power supply, that is plus VCC, to pin number 14. 14 is plus VCC, and pin number 7, this is pin number 7, it is connected to ground terminal or negative terminal of the DC power supply. So first of all we have to connect our DC power supply, positive to pin number 14 and negative to pin number 7. Okay, then now connect in first XOR gate, pin number 1 and 2 are inputs. So pin number 1, it is connected here to input A. These are 4 inputs, so we have to connect pin number 1 to A. It is input A. Okay, then connect pin number 2 to input B. These 4 are inputs. Okay, so we have to select any 2 inputs. So here pin number 1 is connected to A and pin number 2 it is connected to input B, and pin number 3 is output. So we have to connect this wire or pin number 3 to, there are 4 outputs, so we have to connect any out of these 4. We can select any one. So I am connecting here to B. Okay, output B. We can connect out of these 4 we can connect anywhere. Okay, out of these 4. Okay, see here, now see the truth table of XOR gate. See the truth table. So when inputs are 0 0, see here, when inputs are 0 0, then output is 0. See here, see here, there are 4 switches here. So the A and B are inputs, so we have to operate only these 2 switches, A and B. Okay, so see here, the inputs are upper side is low and lower side is high. So when inputs are 0 0, then see here, LED is off, means output is low. So when inputs are 0 0, output is 0. So first step is verified. Then when inputs are 0 1, then output should be 1. See here first input is 0 and second input is high. So inputs are 0 1. Inputs are 0 1. Then for 0 1, output is high because here LED glows. Therefore for 0 1, see here, for 0 1 output is 1. Okay, then for 1 0, see here, input A is high, or input A is 1 and input B is 0. So for 1 0, output should be high. See here, output is high because LED glows. Output is high. So for 1 0 condition, see here, for 1 0 condition, output is 1. Then for 1 1, see here, for 1 1, both inputs are high, both inputs are 1 1, output should be low because for 1 1, output is 0. Output is 0. See here, for 1 1, the output is low because LED is off. LED is off, so output is low. In this way, the truth table of XOR gate is verified. Okay, then XOR as controlled inverter. See the logic diagram. Here 4 XOR gates are connected. 4 XOR. In first XOR gate, 1 2 inputs, 3 number pin output. In second XOR gate, 4 5 inputs, 6 output. In third XOR gate, 9 10 inputs, 8 output. And in fourth XOR gate, pin number 12 13 are inputs and pin number 11 is output. So we have to make the connections in this manner. See the logic diagram of 4-bit XOR as controlled inverter. Okay, so first disconnect this circuit, except power supply connections, okay. Then see here, this is the logic diagram. We have to short pin number 1 4 9 and 12. We have to connect these pins together. We have to connect pin number 1 4 9 and 12 together because these pins are shorted, pin number 1 4 9 and 12, and then it is to be connected to either high or low. So when this input is connected to 1, then we have to connect here to plus VCC, and when it is to be connected to to be connected to ground, then we have to connect it to negative. Okay, so see here, first of all we have to short pin number 1 4 9 and 12. Okay, so connect here. See here, this is pin number 1, then 1. See here, 1 4 9 and 12, 1 4 9 12. See here, this is 1, then 4, okay, then 4 to 9. See here, 4 to 9, 1 4 9 and 12. See here, 1 4. So I have shorted or I have connected pin numbers, pins 1, then 4, this is 4, pin number 1, 4, then 9, this is 9 and 12. I have shorted these pins. Okay, according to this logic diagram. this logic diagram. 1, 4, 4, 9 and 12. These pins are connected together. Then we have to keep this input high. We have to keep this input high or 1. So I am connecting from pin number 12, one wire here, wire to pin number 12, and I am connecting this wire to plus VCC so that these inputs becomes high. Now these inputs are high because these inputs are shorted and connected to plus VCC. Okay, then see here, pin number 2, it is input A. Pin number 2, it is input A. Okay, so see here, this is pin number 2, this is pin number 2, and I am connecting this pin number 2 to input A, because pin number 2 is input, it is input A. Okay, then pin number 5, it is input B. Pin number 5, it is input B. See here, this is pin number 5 and it is input B. It is to be connected to input B. Okay, this is input B. Then pin number 10, it is input C. Pin number 10, see here, this is pin number 10, it is input C. See here, this is input C. Okay, then pin number 13, it is input D. Pin number 13, see here, this is pin number 13 and I am connecting this input to D input. This is input D. Okay, then see here, what are the output pins? Pin number 3 is output A bar. Pin number 3, that is output of first XOR gate. Pin number 3. Okay, output of first XOR gate, that is pin number 3. It is output A bar. It is output. These are outputs and these are inputs and these are outputs. Okay, so pin number 3, it is A bar output. Then pin number 6, that is output of second XOR gate. Output of second XOR gate. Pin number 6, see here, this is pin number 6 and it is, I am connecting this output to B bar, that is output B bar. Okay, pin number 6. Then pin number 8, okay, output of third XOR gate. Output of third XOR gate, that is pin number 8. Okay, see here, this is pin number 8, this is pin number 8 and I am connecting it to C bar output. It is C bar output. These are A bar, B bar, C bar and D bar. So it is C bar output. Then pin number 11, it is D bar output. See here, this is pin number 11. See here, this is pin number 11 and I am connecting this output of fourth XOR gate, pin number 11, to D bar output. Okay, it is D bar. It is D bar. So in this way connections are made. Now when this invert is 1, then XOR gate acts as inverter, and when this invert is low, then the same input and outputs are same. Input and outputs are same when invert is low, and when invert is high, then it inverts the input. That is, when input is low, output is high. When input is high, output is low. Okay, now this is a 4-bit controlled inverter. So see here, when invert is 1, see this chart. See here, when invert is 1, then see here, when inputs are 1 0 1 0, then outputs will be 0 1 0 1. Outputs are 0 1 0 1. So see here, so inputs should be 1 0 1 0. See here, these are the inputs. So input should be 1 0, sorry, 1 0, then 1 and 0. 1 0 1 0. See here, 1 0 1 0, 1 0 1 0. Okay, here inputs are 1 0 1 0. Here also inputs are 1 0 1 0. Then outputs should be 0 1 0 1. Output should be 0 1 0 1. See here, outputs are 0 1 0 1. Okay, 0 1 0 1. According to this, outputs are 0 1 0 1. Inputs are 1 0 1 0. See here, inputs are see here, inputs are 1 0 1 0 1 0. See here, 1. Inputs are 1 0 1 0. See here, inputs are 1 1 0 1 and 0. Okay, then outputs are 0 1 0 1. See here, outputs are 0 1 0 1. In this way, each XOR gate inverts the input. Each XOR gate inverts the inputs. That is, when inputs are 1 0 1 0, then outputs are 0 1 0 1. Okay, 0 1 0 1. Then we take another example. Here, see here, inputs are 0 1 1 1. Inputs are 0 1 1 1. Then what will be the output? Output will be 1 0 0 0. Outputs will be 1 0 0 0. See here, inputs should be 0 1 1 1. See here, input should be 0 1 1 and 1. Input, see here again, here inputs are 0 0 1 1 1. Inputs are 0 1 1 1 0 1 1 1. Okay, inputs are 0 1 1 1. So output should be 1 1 1 0. Sorry, 1 0 0 0. Output should be 1 0 0 0. See here, output is 1 0 0 0. Okay, in this way XOR gate is called as controlled inverter. It is a 4-bit controlled inverter. Now see here, if the invert is in low condition, when invert is in low condition, see here invert is connected to plus VCC. Now I am connecting this invert to ground. So when invert is low, then same input and outputs are same. See here, when inputs are 1 1 1 1, inputs are 1 1 1 1, outputs are also 1 1 1 1. Now when inputs are 0 0 0 0, when inputs are 0 0 0 0, output is also 0 0 0 0. See here, then take another example. See here, the another example. When inputs are 0 0 0 1, then what will be output? Output will be same. 0 0 0 1. Output is also same. That is, inputs and outputs are same. 0 0 0 1. Output is also 0 0 0 1. See here. Here inputs are 0. See here, 0 0 0 and 1. Okay. Inputs are 0 0. See here, 0 0 0 1, and output is also output should be again 0 0 0 1. See here, output is also 0 0 0 1. Okay. Then another example, when inputs are 0 1 1 1, inputs are 0 1 1 1. See here, inputs are 0 1 1 1. Inputs are 0 1 1 1. Okay, inputs are 0 1 1. Outputs should be 0 1 1 1. See here, output is also 0 1 1 1. Output is also 0 1 1 1. So in this way the experiment is performed. XOR acts as a controlled inverter. Okay, when invert is low, then it follows the input, that is the inputs and outputs are same. But when invert is high or when the control is high, then each XOR gate inverts the inputs. That is, when inputs are 1 1 1 1, outputs will be 0 0 0 0. When inputs are 1 0 1 0, outputs will be 0 1 0 1. Okay, so we will stop here.